Hi everyone. In this tutorial, I'll try to explain how to design a constant current source from a voltage regulator IC. The circuit I will implement in the software Proteus ICs. I've already explained the theory, background and design calculations in my article published at my website www.helptoeducate.com. You can browse through the site and find it in the section Electronics Project. There it is. As you can see, it's already on my website and giving all the details. So without wasting any time, let's get started. To save the time, I've already added the components in the ICs and connected them. What we actually require are these two components. One is LM317S and a resistor. The resistor must be connected at the output pin and the other end should be with the adjustment pin. So this configuration will make it a constant current source. The input should be provided at this input pin 3, while the output can be taken from this point. So this point will provide a constant current. Let me delete this. I don't see a reason why they should be here. Alright, so let me, before I demonstrate it, let me explain one thing. How we will select a particular value of current which we want to set here. For example, if I want to set 5 ampere current or 5 milliampere current or 10 milliampere current, how should I configure it? So let me go to the design calculations. Let's say I require 10 milliampere output current from this terminal. To accomplish this, I need to select a particular value of this resistor which will set my output constant current. And how to find the value of this resistor? We will use this equation, which is V reference, which is the voltage at this terminal divided by the value of R. For this particular application, V reference should always be 1.25 volts. And if I want to set 10 milliampere current, just replace this with 10 milliampere and I get 125 ohms. So if I connect a 125 ohms resistor here, I should get a 10 milliampere output current. So let me check all the values. Let me just randomly put it at 25 volts. This is at 1 kiloamps and this is at 125 already set. Now if I push the play button, as you can see, I am getting the 10 milliampere current. But since it is a constant current source, so it must provide me the constant current even if I change the load or the input. So let's try. If I change it to 2 kilo ohms, and let's see. Again, it is still giving me 10.1 milliampere. Now let me change the input voltage randomly to 30 volts. And if I play, again it is giving me 10.1 milliampere. So it is a constant current source. Let me bring it back to 25 volts. Now if I increase it to 4 kiloamps, let me see. No, it's giving me 5.67 milliampere. It means we are missing something. So can this current source provide constant current for all load values and input voltages? The answer is no. So what's the limits? What are those input voltage and load limits through which we can determine? So The rule of thumb is that the input voltage must always be equal or greater than the drop in the IC and the drop in the voltage in the load. So the drop in the IC is fixed, which is 3 volts. So the drop in the voltage drop in the load plus the voltage drop in the IC should always be less than or equal to the input voltage. If this side exceeds the input voltage, the source will no longer provide you the constant current. Now let's see it by an example. In our example, we had a 10 milliampere output current. So what should be the maximum input voltage or minimum input voltage? So it's 3 volts plus 10 milliampere into the R load. If we fix the input voltage at 25 volts, we see the value of R is 2.2 kilo ohms. So it means this is the maximum load for which the design circuit can provide constant current. Above this load, it will no longer provide the constant current. Let's just check it. If I bring it to 2.2, and this is 125, this is 25 volts. If I play it, it's almost giving me the 10 milliamps. Let me just reduce it a bit. If I reduce 2.1, see, it's providing me a 10 milliampere for the load of 2.1 kilo ohms. Now if I increase it from 2.1, let's say 2.4, and you can see the current has been dropped to 9.11. So it must be remembered that the input voltage must always be equal to the drop in the IC and the drop in the load. So what if I want a load of 3K? For the load of 3K and 10 milliampere current, what should be the input voltage? So if the load is 3 kilo ohms and I want a 10 milliampere, so the drop in the load will be 30 volts plus 3 volts in the IC, so the required input current will be 33 volts or greater. So instead of 25 volts, if I put 33 volts as an input voltage, my circuit will provide me constant 10 milliampere current even for the load of 3 kilo ohms. I suddenly lost it and I got it back. So let's try this. Let me try this. Okay, so now let me put it to 3 and the input voltage to, as we said, 33 volts or greater. So let me put it to 34 volts. It is 125 as being set, and I played. Hooray! I'm again getting 10 milliampere current. So this will now provide me the 10 milliampere current if the load is 3 kilo ohms or less with the input voltage of 34 volts. So you can now play with the input voltage or this load if you want to vary your limits. If you want to vary this 10 milliampere current, you need to change the value of this resistor. But remember the rule of thumb. Input voltage must always be greater than the drop in this and the drop in the load. Hopefully you have enjoyed this tutorial. If you like it, please thumbs up. or subscribe to our YouTube channel or like our Facebook page. For more of such articles, please visit my website www.helptoeducate.com. Thanks for watching. Have a nice day. Bye bye.